All right, this is my Spectra 107B helium neon laser. Bob, I'm sending you a photograph of this as a whole, panoramic photographs, and all this little stuff will be labeled, make it a little easier for you to catch everything. This is the power supply for it. Looks like a standard brick. On the side over here, it's got a little potentiometer underneath there for adjusting the power. I keep mine low in order to try to save as much life off of the tube as I can. This is a little 5 milliwatt HeNe from Hughes to give you an idea of size comparison. This is a chopstick. And then that's the big Spectra Physics beast. We'll start on this end. This is the output coupler here inside this mount. This is the mirror mount. And then these two screws can adjust that, both, you know, X and Y axes, so that way you can get that lined up. Behind this little rubber boot is the Brewster windows that I was telling you about that are directly connected to this quartz tube, which is the capillary. If we can get down in here, you can kind of see that faint line. That's the anode connection right there. That's the first and second anode ballast resistors. These are magnets designed to align the plasma to prevent other lines like infrared from lasing. These guys here are the adjustments for the capillary tube itself, because it is somewhat flexible and you can adjust those up and down and back and forth and make sure that that bore is completely straight. This is your cathode resistor, ballast resistor. This is the entrance to the cathode here, right inside this glass bell. This section here that's all silvery underneath this metal strip, that's where the getter is, and they'll activate that when they first gas the tube. They'll activate that to pull out any extra impurities. This is the cathode bell. That whole section right there is the cathode. That comes through here. This little angle comes down, enters the capillary right here. And then past this point, you have your last adjustment here. This is your Brewster window for this end. And then your high reflector. This is the one that's almost 100% reflective to the red of the neon laser's beam, with its two adjustments there and there. Now, let's fire it up. Beautiful, beautiful plasma glow. So here, you can see it coming out of the cathode, coming down, and then the arc starts going that direction, but it's still a tube all the way through here. And you can see that little tiny red spot, that's actually being reflected off of that Brewster window. And then on this side, you can see a little bit of laser light leak out on my hand here. But on the other side, bright, bright red dot. So that tube runs all the way over here. The charge, the plasma charge, comes through this direction, all the way along this tube. Along this side, comes to that other Brewster window. And you can see the little dot on the very top of that. And that's from the reflection of the Brewster window. And then you've got your output coupler, which is that 99.995% reflective to this red HeNe beam color. And then you've got the beam coming out, which for a helium neon is surprisingly impressive. If you focus this beam down with a magnifying glass or an eye loupe, it will etch into plastic, dark black plastics and such. But she really is a beautiful beast. All that beautiful glass work. Unlike the argon lasers, these guys don't really need to be run. The neon gas doesn't push itself into the tube or exhaust from the tube when it's not in use. It just kind of sits there. They're very stable that way, and they're very nice. Brewster windows, especially in that style, helium neon, the gas doesn't leak past the Brewster windows as it will in the soft and hard seal of the tubes like this, which is going to be a glass bell similar to that, but it'll have the capillary going down the center of it, anode on one end, cathode on the other, and then the mirrors on the outside of the glass tube itself. So it's all one unit rather than having that long thin quartz tube running along and then having the cathode bell separate. Alright, so there you go. Hope this little tutorial helps you. Bye. Thanks for watching.